All of you, can you all hear me? So please type in your chat box. Good evening everyone. So please type in the chat box. Can you all hear me? And can you see the screen clearly? Good evening everyone. Can you please see the screen clearly? Please type in the chat box. Yes, visible. Okay. So if you quickly recall the things, we have seen what is a basic differential equation, of course, of ordinary and partial differential equations. Then we have seen the definitions of order and degree of a differential equation, and we have seen how to identify the given order and degree from a given differential equation. Correct? So then after we have seen forming a differential equations, and then we stepped down to solving first order differential equations. Correct? So in first order differential equations, we have solved using variable separable form. Then we have seen how to solve homogeneous differential equations, and then we have also seen how to convert a given non-homogeneous first order differential equation into homogeneous first order differential equation, and then we solved. Correct? So then we have seen what is something called Leibniz linear equation, which is of the standard form. The standard form of Leibniz linear equation is dy by dx plus some function in terms of x into y is equal to some function in terms of x. This is a standard linear Leibniz equation, and these are the things that we solved till yesterday's class. Correct? Yeah, good evening all of you. Please try to join quickly because we'll go we'll cover a lot of topics today, so please join quickly. So now if you see, this is the standard form of linear Leibniz equation. Correct? So in today's class we'll continue this linear equations a bit, and then we'll move on to something called the higher order differential equations. Correct? So we'll see what is a higher order differential equation and how to solve a higher order differential equation basically. Okay, so now if you see, this is a linear Leibniz equation, and of course you know how to obtain solution of this equation. Correct? I have told you what is an integrating factor if, and if is equal to integral p dx, p of x dx, of course. So if you obtain this, what is this integrating factor, then the solution of this differential equation is y into e power integral p dx, and this is equal to integral q times of e power integral p dx to this whole dx plus constant. Correct? Did we see this in yesterday's class? Please type in the chat box. Did we see this particular solution of this kind of equation in yesterday's class? Hello all of you. So please try to join quickly, and please type in the chat box. Did we see that this is the solution of this particular linear Leibniz equation in yesterday's class? Okay. So now since we know how to obtain solution of a particular type of differential equation, means the differential equation which is of this form, we can, with the help of this particular equation, we can also solve some non-linear equations. Look how to do that. Let us suppose there is an equation of the form dy by dx plus py is equal to q times of y power n. Can you all tell me, this is a linear equation or a non-linear equation? Let us suppose n is not equal to 1, n is something more than 1 maybe. Then can you tell me whether this equation is a linear equation or a non-linear equation? Please tell me, this equation is a linear or a non-linear one? It's a non-linear equation. Correct? Because you can see this n here, and this n is something more than 1, then definitely this is a non-linear equation. Now normally in this point we know only how to solve this linear differential equations. Correct? But now we'll do something so that this equation which is non-linear by itself will get converted to a linear differential equation. Okay, in yesterday's class, if you remember, we have discussed something called integrating factor. Correct? And what is integrating factor? The factor which when multiplied to a inexact differential equation will convert the differential equation to exact differential equation. Correct? This is what we learned about integrating factor. So now in today's class we'll see something which, how to convert this kind of non-linear differential equations to linear differential equations. Clear? So now if you make a little adjustment, see, and this equation is known with a special name called Bernoulli's equation. Of course, this equation is called something called Bernoulli's equation. Okay, Bernoulli's equation. Of course, in mathematics there is one more Bernoulli's equation in fluid mechanics. Please don't get confused with that. Okay, this is a Bernoulli's equation in mathematics. So now if you can convert this, if you can slightly manipulate this, dy by dx plus py is equal to q into y power n. If you divide the complete equation with y power n by y power n, then this is how the equation look like, which means y power minus n into dy by dx plus this p is here, and y by y power n minus 1 could be like something like this, is equal to q. Correct? Can you all understand? This is how the equation gets converted if you divide it by y power n. Yes or no? Please respond. Can you all understand that this is how the equation gets converted if you divide with y power n? Now, if I make a little substitution, that let y power n minus 1 is equal to z. Or sorry, this is 1 minus n, because this is 1 minus n, because this is y and y power n is in the denominator. So dy by dx into y power minus n plus p into y power 1 minus n is equal to q. Correct? So now if you can make this, so now if you treat this y power 1 minus n as z, some variable, okay, this is some variable that which I am introducing newly into this differential equation. So let y power 1 minus 1 is equal to z. Now can you tell me, if I differentiate this with respect to x, what's the term I will be getting? 1 minus n into dy by 1 minus n into y power 1 minus n minus 1 into dy by dx is equal to dz by dx. This is what I will be getting. Correct? Now this one and this one gets cancelled, which means 1 minus n times of y power minus n into dy by dx is equal to dz by dx. Yes or no? Now if I substitute this y power minus n, or else let me try to get expression for this. Y power minus n into dy by dx is equal to 1 by 1 minus n into dz by dx. This is what you have. Correct? This is what you have by making this particular substitution here. Now, once if you make this substitution and if you are getting this particular term, then in place of this y power minus n into dy by dx, which is here, you can see there is one y power minus n into dy by dx here. In place of this, can I substitute this term 1 by 1 minus n into dz by dx? Can I substitute this term here in place of this y power minus n into dy by dx? Please tell me, can I do that? Yes or no? Please type in the chat box. Be attentive. Can we substitute this dy by dx into y power minus n as 1 by 1 minus n into this term? So if you are substituting this equation which is here gets converted to 1 by 1 minus n into dz by dx plus p, we are not changing because p is completely a function of y, and what are the substitution we are doing? That completely in terms of y here. So here p is completely a function of x, so there is nothing to change in terms of p. This y power 1 minus n which is here can be replaced with z is equal to q is again a function of x, so this remains as it is, and this 1 by 1 minus n is just a number and it's a constant, so we can write this equation as dz by dx plus 1 minus n times of p into z is equal to 1 minus n times of q. And of course this 1 minus n is just a number. Can I call this as a linear equation now? Yes or no? Please tell me, can I call this equation a linear equation if both p and q are just functions of x? Correct? Can I convert this? Can I call this a linear differential equation? Yes or no? Please tell me. Yes. So now we have seen, basically given is a non-linear differential equation because you have some higher powers of y, but by making some substitution which is feasible here by this form, we have converted this particular non-linear equation into a linear equation. Correct? And to be more precise, can I call this is a linear Leibniz equation because you have some dz by dx plus some function in completely in terms of x into z is equal to again some function completely in terms of x. So can I call this is a form of Leibniz linear equation? Yes or no? If this is a Leibniz linear equation, can we solve this? If this is a Leibniz linear equation, see, in yesterday's class we have seen, if this is a given Leibniz linear equation, then this is how we obtain the solution of this differential equation. So now, when we convert this given nonlinear equation into this particular differential equation which is linear and to be special, it's a Leibniz linear equation, we know how to solve this equation, which means if you are obtaining the solution of this equation, that is equivalent to the obtaining the solution of this equation. So by making some substitution, we are obtaining a solution of a non-linear differential equation. Is that clear to all of you? Did you all understand how to convert this non-linear equation into Leibniz linear equation and solve this? Yes or no? Please type in the chat box. Yes. So this is one way where non-linear equations of this particular kind can be converted to linear differential equations. And in GATE exam, it was asked till 5 times. Okay, they'll give you some equation like this, and they'll ask you what is the substitution you need to make to convert this Leibniz linear, this non-linear equation into Leibniz linear equation. Okay, this question came around 5 times in GATE till now. So please be attentive, and the substitution that you need to make is this particular substitution whenever the equation is in this form. Okay, and I hope you understood this. There is no difficulty here. It's simple basic integrations and substitutions. Okay, so now there is one more kind of special equations. Look, if the differential equation is of the form f dash of y into dy by dx plus f of y into p is equal to q, where p comma q are functions of x alone, where p comma q are functions of x alone, functions of x alone. Okay, so if you have things like this, now see how to convert. This is a nonlinear equation clearly, because you have seen this is some function of y. Of course, this is function of y. That means this is also a function of y, and there is some product of terms involving y and dy by dx. So can you sense that this is a nonlinear equation? First of all, please tell me, can you all sense that this is a nonlinear equation? Because it involved some terms which are containing product of y's and dy by dx. Correct? Now let us see how to convert this particular nonlinear equation into linear equations again. So if you try to see that, let f of y is equal to z. If you make this f of y is equal to z, this means if you are differentiating this with respect to z, I mean with respect to x, f dash of y into dy by dx is same as dz by dx, which means if you are making this substitution, that this treating this f of y as some variable z, then definitely in place of f dash of y into dy by dx, you can substitute dz by dx. So this equation, initial given equation, gets converted to dz by dx plus p times of z is equal to q. This is what a Leibniz linear equation again. Correct? So these two are two special cases of nonlinear differential equations, where by making a substitution you can convert them into Leibniz linear equations, for which solution is already attained. Okay, now there is one point that I would like to talk here. You have seen whenever this n is equal to 1, means dy by dx plus py is equal to q into y power n. This is what the analysis you obtain. But when n is equal to 1, you see this term doesn't exist. Correct? Because the denominator is 0. Can you suggest me something that you can do here? Whenever n is equal to 1, the denominator which is here is getting to 0. So can you tell me something what to do if n is equal to 1? Anything? Any suggestion by you? Can we do something when n is equal to 1 and still apply this? Can convert this into linear Leibniz equation? Any method? I'm giving you some time, so please think. Look, whenever n is equal to 1, it's clear the denominator here goes to 0. So can you tell me when n is equal to 1 how to go forward in this way? Any suggestion by any one of you? Nothing? Look, I'll tell you. Okay, variable separable. Yeah, that's what you can do. So dy by dx plus p times of y is equal to q into y power n. So if y is equal to 1, this is what you have. So which means dy by dx plus p minus q into y is equal to 0. And now if you see, if both p and q are functions of x, then definitely p minus q is also a function of x. Then you can do different methods for solving this. You can convert this into variable separables, or you can apply Leibniz linear equation here itself by taking the right hand side as 0. So there are multiple ways in which you can solve this question. Okay, you can convert this into variable separables also. That could be one easier way, but of course depending upon this complexity of the function. Okay, is that clear to all of you? And did you understand this, how to convert equations of this particular form to this? Because sometimes it's very often in exam you will be getting some questions like this: secant square y into dy by dx plus tan y into x is equal to something. Tan y into x is equal to some function, maybe e power x, something like that. Then in the exam when you see this question, don't get panicked, because you are seeing tan y and secant square y in the question, and most probably secant square y into dy by dx is there. If you take a little substitution, let tan y is equal to t, that's it. Your substitution will give you secant square y into dy by dx is equal to dt by dx. So you can convert this equation, and this equation gets converted to dt by dx plus tan y is equal to t. So t times of x is equal to e power x, which is a pretty much simple equation to solve. Okay, I hope things are clear for us by this moment. Yes or no? Please respond. Do everyone understand how to convert the couple of non-linear equations in that particular kind to linear equations and then to solve them? If you are okay with this, we'll continue with the problems. We have 2-3 problems left, and then we'll move on to higher order differential equations today. Okay, so fine. Then this is the first question. Please try to solve. It was a question from 2019. Easy. So please try to solve this question. The families of curves represented by the solution of the equation dy by dx is equal to minus of x by y whole power n, when n is -1 and n is 1 respectively are. Means when n is equal to -1, what could be the solution of this equation? Means the solution of this equation represents which of these following, and similarly when n is equal to +1, what could be the second part of the solution? So please try to do this. So please try to do these questions. They are simple questions actually. So the given equation is dy by dx is equal to minus x by y whole power n. Okay, when n is equal to 1 and when n is equal to -1. What's the thing that you have here? Please try to solve and tell me the answer for this. This question was asked in GATE 2019. You know, very recently. So please try to solve this. And this is one good question in first order differential equations. C is the answer, Mauli. Is it? I think one of the options should be, the option should involve cycles, definitely. Okay, C is the answer. Let me check. So first of all, when n is equal to -1, if n is equal to -1, can I write dy by dx is equal to minus y by x? Can I write this? Yes or no? Now, if I can write this, if you apply variable separable form, 1 by y dy is equal to minus 1 by x dx. So this is a variable separable form. So if you integrate the things, this is ln y and this is minus ln x. So if you shift to the left hand side, this will be plus ln x is equal to constant, and this implies xy is equal to constant, and you know this represents a hyperbola, correct? So when n is equal to -1, for the first case, when n is equal to -1, the option that you got is this represents a family of hyperbolas. In yesterday's class, I have shown you how this xy is equal to constant represent a set of hyperbolas. Did we do that? Please respond me. Did I tell you that in yesterday's class xy is equal to c represent a family of hyperbolas, and I have given the graphs also, correct? Yes or no? Please respond. Did we talk about this in yesterday's class? All of you? Yes, we have talked. So which means for n is equal to 1, the answer is hyperbolas. So these two options are wrong, because here it should be hyperbolas, and which is not present in option B and D. So the answer is something in between A and C. Now let us go for the case when n is equal to +1. So dy by dx is equal to minus x by y when n is equal to 1, of course. So this implies y dy plus x dx is equal to 0. So if you are integrating the things, of course, y square plus x square is equal to 2c, and this represents a circle because you see the denominators of both x square and y square are same here, correct? Even if you shift this, you will be getting x square by 2c plus y square by 2c is equal to 1, and you know this is nothing but square of length of semi-major axis, and this is nothing but square of length of semi-minor axis, because you know the general ellipse equation is x square by a square plus y square by b square is equal to 1. So this a represents length of the semi-major axis and b represents length of the semi-minor axis, and you know a circle is a special case of an ellipse both when length of semi-major axis and semi-minor axis is same, and this is what the case you have seen here. So this represents undoubtedly some family of circles, correct? So this is circles. So parabolas is wrong and circles is correct. So hyperbolas and circles. Option C is the correct answer. Okay, I hope this question is very much easy to do. Of course, you take some maybe 30 seconds for doing that and some more 30 seconds for doing that. Okay, so maybe 1 or 1.5 minutes could be hardly enough to solve this, but it's a recent GATE question. Clear? So can I go ahead for next question? Please respond. Can I go ahead for next question? Yes. Okay. So this is one next question that was asked somewhere in 2017. So please try to answer this question. The equation is something like y into root of 1 minus x square dy plus x into square root of 1 minus y square dx is equal to 0. This is how the differential equation was given in 2017. So please try to solve these differential equations, and of course the options are also given. One of these options is the solution of this particular differential equation. So please try to solve this and tell me the answer. Look, in exam, if you are not, of course there won't be such difficult questions as well, but in exam, suppose if you are not able to solve the differential equations, in options you will be given, if you are given solutions like this, then differentiate all the 4 options, then definitely dy by dx from one of these particular options will satisfy this equation. Okay, but of course that is so much of time taking if questions are like this, but that's the only way then you can obtain the solution if you don't know how to solve the given differential equation. Okay, but of course I think that's not the case, that need not be done here. The question is simple. Option C, Devi, square root of 1 minus x square plus square root of 1 plus y square. 1 plus, square root of 1 minus y square is equal to constant. Dinesh, you two telling it C. Mauli, C. Okay. So, whoever didn't get this, please, Bhagavi, C. Okay. C. Umesh, fine. Okay. So, see here. Now, y into root of 1 minus x square dy can be written as minus x into square root of 1 minus y square dx. Correct? Now, if you shift this 1 minus y square to the left and this root of 1 minus x square to the right, we will be having y by square root of 1 minus y square dy is equal to minus x by square root of 1 minus x square dx. This is what you have. Correct? Now, this is in variable separable form because you know the left hand side is completely a function of y, and the right hand side is completely a function of x. So now, if you integrate these equations on both sides, then you know I told you one particular formulation. If you see f dash of y divided by root of f of y. Did we give any formula for this? When I am giving you the basic formulas for integration, did I give you any formula for this kind? Yes or no? Please respond. Did I give you any formula for this kind of special integration? Of course, when you have a dy here. Correct? Yes. So now, if you see, the differentiation of this 1 minus y square is minus 2y. So, yes, of course, 2 root of f of y. That's what I have given you. But okay, now the differentiation of this 1 minus y square is minus 2y. But if you see, there is only y in the numerator. So can I multiply it with a minus 2 and can I divide it with a minus 2 as well? Similarly, can I multiply it 2 and can I divide with 2 here is equal to 1 by 2? Yes. So now if I do this, I can get minus 1 by 2 which is outside of this integration and minus 2y which is the derivative of this 1 minus y square, and this particular integration as per this result it gives me 2 times of root of 1 minus y square. And this is also is equal to 1 by 2 into 2 times of root of 1 minus x square plus constant, since you have already indicated. Now this 2 gets cancelled and of course you will be getting square root of 1 minus x square. If this minus root of 1 minus y square goes to the right hand side, root of 1 minus y square. And since this is an arbitrary constant, it doesn't matter on which side this arbitrary constant lies in this solution. So this is equal to C. So this is the solution of this, which is in option C here. Okay. This is a very easy question, but the way the equation was written, it looks a bit, time taking and all, but it's a simple equation. Whenever constants are not there, you can always adjust the constants. Okay. It's not like since we need minus 2y and there is only y here. We can multiply minus 2 and you can divide with 1 by minus 2. Okay. Is that clear to all of you? Did you all understand this question? Can I go for the next questions? Yes or no? Please tell me. Can I go for the next question? Yes? Okay. So this is one question that was asked again in 2017 for triply. So consider the differential equation. This is one differential equation which you are having here is equal to sine t till this moment, and of course some boundary condition is also given. Then there exists a unique solution for this differential equation when t belongs to the interval. When t belongs to the interval, one of the intervals is given here. So please try to solve this and tell me the answer. Yes, so please try to solve this question and tell me the answer. And meanwhile, if you are liking the content we are sharing here, please like the videos and share them. And also, if you are here for the first time, you please subscribe the channel, okay? So that you'll be getting notified whenever there is a a lecture that we are launching on this platform. Consider the differential equation. Of course, some differential equation is given. T square minus 81 into dy by dt plus 5 times of t into y is equal to sine t, with y of 1 is equal to sum 2 pi. So please try to solve this equation, differential equation, and tell me what could be the answer. Of course, I think I am blocking the board. Now you can see the options clearly. There exists a unique solution for this differential equation when t belongs to the interval. One of these 4 options is correct. So please try to solve this. And of course, when some boundary conditions are given, then there exist unique solutions. I mean, we go for particular solutions, so that's okay. So please try to solve this question. I hope all of you can see the question, correct? I think the font is a bit short today, but it's readable still. So what is the differential equation? Okay, I think you're taking some time, so let me try to help you. So solution. If you see, this is t square minus 81 into dy by dt plus 5t by this thing is equal to sin t. Now, can I write this equation as dy by dt plus 5t divided by t square minus 81 on y is equal to sin t divided by t square minus 81? Yes or no? Can I do this? Can I convert the given differential equation into this? Now, if you talk about the integrating factor if this is a Leibniz linear equation, so e power integral 5t divided by t square minus 81 dt. This is what you have. Okay. Now, what's the differentiation of this? Differentiation of t square minus 81 is 2t, and we have t in the numerator. So forget about the constant. We can write 5 by 2. Okay. E power 5 by 2 integral 2t by t square minus 81 dt. Can I write this? Yes or no? Because I'm adjusting some numerator so that I'll be getting this numerator as a function, as a differentiation of this denominator. That's it. So this is equal to e power 5 by 2 into, now integration of this dt 1 by t square minus 81. Can you tell me what's the integration of this? We have the differentiation of the denominator in the numerator. So can I write this log t square minus 81? Yes or no? Which means this is equal to t square minus 81 whole power 5 by 2. Correct? Will you all agree with me if I say you that t square minus 81 whole power 5 by 2 is the integrating factor for this? Yes or no? Please respond. Will you all agree if I say this t square minus 81 whole power 5 by 2 is the integrating factor for this particular equation? All of you, please respond. Did you all understand the things till here? Now, we got an integrating factor, and integrating factor IF is equal to t square minus 81 whole power 5 by 2. Now, if you talk about the solution, then definitely solution is equal to, or else let us write solution is y into t square minus 81 whole power 5 by 2 is equal to integral, what is q? Sin t divided by, sin t into the integrating factor is t square minus 81 whole power 5 by 2 dt plus some constant. Can I write this as the solution? Which means, can I write y is equal to integral sin t into t square minus 81 whole power 5 by 2 dt divided by t square minus 81 whole power 5 by 2 plus some constant divided by t square minus 81 whole power 5 by 2. Can I write this? Can I tell that this is the solution of this differential equation? Yes or no? Are you all clear till this moment? Can I tell you that this is the solution of this differential equation? Yes or no? Please tell me. Can I tell that this solution is the solution of the given differential equation? Value of q. I think q is 1 by t square minus 81 is also there. So, yeah. This is t square minus 81 whole power 5 by 2, of course. And this is t square minus 81. Correct? This is, sin t by t square minus 81 and into t square minus 81 whole power 5 by 2. Correct? Now tell me one thing. If this solution has to be unique, there should be some value for this c. Correct? Means the solution will be unique only if there is some value for c. And one more thing, one very important thing, this term which is in the denominator should not be equal to 0. Correct? Of course, this will cancel and finally we'll be getting 3 by 2 here. So no issue with this integration. But if this solution has to exist, can I tell for this c to be existing, for some finite value of c, if this complete solution has to have a unique solution, this denominator should not be 0. Correct? Yes or no? This denominator should not be 0, which means t square minus 81 should not be equal to 0, which means t should not be equal to plus or minus 9. This is the condition for which this term exists some finitely and we'll be getting a unique solution, because this c will be given a finite value when some boundary condition is substituted, which is given some y of 1 is equal to 2 pi something. Okay, so this is the condition, which means for this given equation to have a solution, then definitely t should not be equal to plus or minus 9. And if you see in all these three options, we have the involvement of either plus 9 or minus 9. Clear? So which means A is the only answer which is suitable for this operation. Is that clear? T should not be equal to plus 9 or minus 9 for the solution to be existing for this given differential equation. So if you can understand that, then you know out of these three intervals, we have minus 9 here, we have minus 9 and plus 9 here, and we have plus 9 here. So we need to eliminate all these three options, and A is the correct option involving minus 2 to 2. I hope you understood this question. Okay. Clear? So can I go for the next question? Or do we have any doubts at any moment? Yes? All of you please respond. Clear? Yeah, ask me to ask, please. Please tell me. What's your question? How 10 became 9? Sorry? Where? How 10 became 9? Where is it? At which step? How 10 became 9? See, look, in the interval minus 10 to 10, we have all the values from minus 10 to 10. Correct? So, you know, minus 9 and 9 are here. Okay. So that's why since 9 and minus 9 are in these intervals, we have eliminated the options from 0 to 10, then minus 10 to 0, and also from minus 10 to 10. Okay. And minus 2 to 2 is somewhere here, which is not involving either plus 9 or minus 9. Okay. So these are options which are involving minus 9 and plus 9. Okay. I hope you are clear. Yeah. Okay. So please try to solve this. I think this was asked in 2020 last year. I mean this year in GATE. So please try to solve this question. Consider the initial value problem below. Okay. This is the problem. dy by dx is equal to 2x minus y. Okay. And y of 0 is equal to 1. Then what's the value of y at x is equal to log 2 to the base e? This is the question that is from 2020 GATE. So x is equal to log 2, which means log 2 to the base e. So please try to solve this. Look, in examination, if you are given a first order differential equation, I'll tell you how to solve the question. Okay. As soon as you see the equation, first of all check whether the equation can be converted to variable separable or no. Okay. Please check that. Please check that whether the equation can be separated to variable separable form or no. Then if it's possible, solve that. If it's not possible, then see whether the equation is homogeneous or not. If it's homogeneous, then solve. Then if it's not homogeneous, check whether the equation falls into which special case of non-homogeneous equations. If you know how to solve non-homogeneous equations, so you can solve. Or else you can apply linear Leibniz equation to solve the question. So check for these 4 things and try to solve all the first order differential equation questions. Okay. So by the way, what's the answer for this? dy by dx is equal to 2x minus y. You see, this equation cannot be separated into variable separable form, and also it's not a homogeneous equation. Correct? It's a non-homogeneous equation involving some 2x and y. So can we convert this equation as dy by dx? This minus y, which is on the right hand side, let us bring that to left hand side, is equal to 2x. Now this is a Leibniz linear equation with a value of coefficient for y is equal to 1. So this is a Leibniz linear equation. So you can solve this easily. Okay. So please try to solve this. You know, integrating factor is e power integral 1 dx, which is nothing but e power x. So if you write the solution for this, y into e power x is equal to integral 2x into integrating factor again, which is e power x dx plus constant. I told you one simple method to evaluate these integrations whenever you have the algebraic function in the first term and an exponential function in the second term. Do you remember? Do you remember this? I told you one simple way to integrate product of two functions whenever the first function is algebraic and second function is exponential. Correct? So let us try to do that. Y into e power x is equal to 2 is a constant, so I am taking 2 out. So integration of x into e power x is x into e power x minus e power x plus constant. This is what you have. Do you remember this? Okay, many people are getting different answers. Look, whoever is not there in the basic calculus course, I'll tell you something. If you have one function as algebraic and other function as exponential, then the answer for this integration is if this is first function and if this is second function, and of course the first function is again a polynomial function and second function is some exponential function. If you have this, integration is x square, which is the first function, into integration of this second function, e power x. Now you have taken plus here, so take minus. Use plus and minus signs alternatively. Now the first function here is 2x square, so the differentiation of this x square is 2x into the integration of this function, which is again e power x. You have taken minus, so take plus again. Now here the function is 2x, so the differentiation of this 2x is 2, and the integration of this e power x again is e power x, minus differentiation of this 2 is 0, and from here every term goes to 0. So the integration of this is x square into e power x minus 2x e power x plus 2 times of e power x, plus constant, of course, some arbitrary constant you will be writing. So plus constant, this is what you have. Okay, I told you this technique if you remember. Did you all remember? In course of basic calculus we have solved this. Correct? Yes. So now the solution for the given differential equation that we got is y into e power x is equal to something that we got here, 2x e power x minus 2 times of e power x plus constant. So if you cancel, y is equal to 2x minus 2 plus c into e power minus x. This will be the solution. So now let us take for the boundary condition. What is the boundary condition that's given? Okay, you are getting different answers, I know, because you are making some calculation mistakes while using virtual calculator. Okay, so see here. Now, what is the condition that's given? Consider the initial value problem below. Then what's the value of y at x is equal to log 2? Okay, then what about c? Okay, this condition is given to calculate c. Y of 0 is equal to 1. So put x is equal to 0 and y is equal to 1 simultaneously in this equation. This implies 1 is equal to 2 times of 0 is 0 minus 2 plus c. So c is equal to 3 times. I mean 3 is the value. So is it that c is equal to 3? Yes or no? C should be equal to 3. So this equation is y is equal to 2x minus 2 plus c times of, I mean where c is 3, so 3 times of e power minus ln 2. This is what it's given, correct? Okay, let me write this ln 2 here. 2 times of ln 2, which is y is equal to 2 times of ln 2 can be written as log 4 to the base e plus 3 times of e power minus ln 2 is nothing but e power 1 by 2 minus 2. So this is what the value you need to find. Let us use a virtual calculator and try to get that value. Okay, so 3 into 1 by 2, okay, minus 2 and log 4 to the base e. Okay, so yeah, let us try to calculate using some virtual calculator. Yes, so see here, log 4 which is ln 4 which is log 4 to the base e minus 3 by 2, I guess we have, okay, plus 3 by 2 and minus 2. So see here, plus 3 by 2 minus 2. So 0.886 is the answer. So y is equal to 0.886. So since they asked it to round off to 3 decimal places, this is the correct answer. Yeah, I know. You all know how to solve this particular differential equations and how to obtain the answers. But the only thing that you do is calculation mistakes. I know. Okay. But because of doing them, you'll lose marks in examination, and you will get something which you don't deserve in exams. Okay. So 0.886. Okay. Anyhow, if you practice calculations a bit, then all calculations will be very easy for you. Okay, I hope this is clear. So I'm going for the next question. Okay. This is a question. The family of curves that is orthogonal to xy is equal to constant. So where there is one set of curves or one family of curves, xy is equal to c, which are hyperbolas, of course. So please tell me what's the meaning of orthogonal. Look, exponent minus. Okay. I don't understand Kalimula. Exponential minus. Okay, something you're asking, you please try to ask that in English if possible. Okay, so what's the meaning of orthogonal? They are intersecting perpendicular to each other, correct? So suppose if you have some curves like this, which are given by f of x comma y is equal to constant, And if you have some other set of curves which are given by g of x comma y is equal to constant, and for example if the curves are looking something like this, then at this point of intersections if you draw tangents they will be perpendicular. That's what it means. You are having, these are perpendicular. So this is called a system of orthogonal pair of curves. Basically f of x comma y is equal to constant is some curves which I have drawn in yellow, and g of x comma y is equal to constant are some curves which are again intersecting here. So these two are orthogonal. If these two are orthogonal, then definitely product of their slopes has to be -1. So first of all, let us try to find what is dy by dx from this value. Xy is equal to constant, so which means x into dy by dx plus y is equal to 0, which means dy by dx is equal to minus y by x. Correct? This is what you have. So if you want the slope at any point for this particular curve, the value of the slope is minus y by x. So now if the slope of this curve is minus y by x, now what should be the slope of the curve which is perpendicular to this? Can you tell me what should be the value of dy by dx for the curves which are perpendicular to these curves? Because product of the slopes when both are perpendicular is -1. Correct? So can you tell me what should be the slope of the curve which you need? This is x by y. Now this is a differential equation which is y dy is equal to x dx. So if you integrate this, this is nothing but y square minus x square is equal to some constant. Okay, of course 2 times of constant, but again the 2 times of constant is also a constant. Okay, so y square minus x square is equal to constant. It's given here in option D. Did you understand how to form the differential equation based on the lines that are given here? It's given the family of curves that is orthogonal to this family of curves. So if xy is equal to constant is a family of hyperbolas, then you'll be getting some other hyperbolas which are perpendicular to that. Okay, yeah, answer is D. And this is how two family of curves intersect orthogonally actually. Fine. I hope all of you are clear with this. Did you all understand how did we obtain that dy by dx for this value is x by y? Okay. So can I go for the next question? I hope there is nothing difficulty in this question. So I'm going for the next question. All of you please respond. Okay. This is the question. So please try to solve this. Okay, this is a higher order differential equation. Fine. So we'll try to look quickly to higher order differential equations. What are higher order differential equations and how to solve them? Higher order differential equations. Okay. So before starting this higher order differential equations, let me quickly recall all the topics that we learnt in first order differential equations. Correct? So in first order differential equations, basically we have started with how to convert a given differential equation into variable separable form and then how to integrate. See, this is completely new topic. So whoever is joining now, you please try to stay focused here. Okay, and whoever is already attending, so please let us quickly recall. So in first order differential equation, we have started with conversion of given differential equation into variable separable form, and then we have seen if conversion of the given dE to variable separable form is not possible, we have seen how to convert them into homogeneous equations and to solve them, and then we have also seen how to convert a given non-homogeneous equation into a homogeneous equation, and then after that we solved few questions by taking Leibniz linear equation, and also we have seen how to convert a couple of special kind of differential equations to Leibniz linear equations and to solve them. Correct? These are the topics that we dealt in past 2 days. Yes or no? Correct? Are these the topics that we finished in past 2 days? Yes or no? Please respond. So now we'll start higher order differential equation. And what's the main difference between a higher order differential equation and a first order differential equation? As the name implies, they are of some higher order. Now that general formulation of any differential equation of higher order is given like this: d power n y divided by dx power n, which is the nth derivative of y with respect to n, with respect to x, plus some function into the n minus 1th derivative of y plus k2 into this is n minus 2 of y divided by dx power n minus 2 and so on plus k n times of y is equal to some function f of x. This is the standard form of any first order, higher order linear differential equation. If all these k1, k2, kn are functions of x alone, k1, k2 and so on, kn are functions of x alone. So this is the standard notation of any higher order linear differential equation. Correct? If these are functions of x alone, then this is a linear higher order differential equation. So this is linear because we don't have any product of the dependent variable and its derivatives, or also we don't have any higher powers of y. Correct? So now if n is equal to 2, then the equation looks something like d square y by dx square plus some function into dy by dx plus some other function into y is equal to some function. It's called a second order differential equation because order of a dE is nothing but the order of the highest order differential that's involved in that equation. So since if you are taking this as d square y by dx square, then second order derivative is the highest order derivative that's involved in this equation, and we call this a second order differential equation. Similarly, if n is equal to 3, we call this as third order, and it goes on as that way. So now if this is any ordinary differential equation of higher order, then let us see the procedure. Nth derivative term should have a coefficient. Okay, you can have, let us suppose k naught into dy by dx and so on. Now if I divide the complete equation with k naught, I'll be getting some functions here. Okay, so that could be fine, because even if you are dividing with this k naught with this complete equation, then this is what it occurs. Correct? Okay, Sai Krishna, I hope you understood this. Yes? Okay, so fine. See here. Now if you have any higher order differential equation, let's see how to solve the higher order differential equations. Look, let us see how to solve. Let d is equal to d by dx, and similarly d square is equal to d square by dx square, and d cube is equal to d 3 by dx cube, where d is a differential operator. This is d is differential operator. Okay, with the help of this differential operator, we will be able to solve the differential equations without actually integrating them. So let's see how to solve that. Okay, so similarly and so on. Similarly, d power n is nothing but the operator d power n by dx power n. So suppose if you are writing d square x square, which means d square by dx square operating on x square, which for which the answer is 2. Correct? So this is how these operators are generally involved. Now if you have any differential equation, look, initially we have the terms like d nth derivative of y with respect to x plus some function into n minus 1th derivative of x and so on plus k n into y is equal to some function f of x maybe. Correct? Now if this is a higher order differential equation, I told you this equation is said to be a homogeneous differential equation if the f of x is equal to 0. Means if it contains only the terms till here, so then we call this differential equation as homogeneous. I also gave you some examples where you will be getting equations like d square y by dx square plus 4 dy by dx plus y plus sin x is equal to 0. And they'll ask you whether this equation is a homogeneous equation or no. Okay, you should be very careful. Sometimes they bring this f of x onto the left hand side and they'll equate the right hand side to 0. But still, this function is, this differential equation is a non-homogeneous differential equation, because till this here all these terms can involve y, but this term it doesn't involve any y, any dependent variable, and this is completely a function of independent variable. Okay, so generally this is a standard form, but sometimes what they do, this is a non-homogeneous equation because we didn't specify this f of x is equal to 0. But sometimes what they do, they'll shift this f of x onto the left hand side, something like this, and equate to 0, and they'll ask you whether the equation is homogeneous or not. And the first option, definitely they'll give you homogeneous. So don't fall in that trap. Clear? Did you all understand where you can commit a mistake if possible in determining the homogeneity of a differential equation which is of higher order? Yes or no? Please respond. Did you all understand? There can be one way where you can be fallen into trap if they give you some equation like this. Sometimes they'll shift this f of x to the left hand side and they'll show 0 on the right hand side. Okay, where you may feel that's the homogeneous, but actually it's not. Fine. Now, how to obtain the solution of this? Look. Now, if you apply this operators here, can I write d power n by dx power n plus k1 into d power n minus 1 by dx power n minus 1 and so on till kn operating on y is equal to f of x. If I am writing all these are operating on y, that means this is nothing but d power n by dx power n operating on y plus k1 into d n minus 1 the derivative operating on y and so on. So now if I write this, we have d power n plus k1 into d power n minus 1 and so on plus kn into y is equal to f of x. Can I write this? Now if you are writing this, can I, in a nutshell, I can write some function in terms of d, which is a polynomial function, of course. So if you see, this is some polynomial depending upon the degree of, order of differentiation. So if this is some polynomial d power n plus k1 into d power n minus 1 and all, can we write this complete equation as this function f of d operating on y is equal to some function f of x. Correct? Now this is the given differential equation, which is, this equation is same as the given higher order differential equation. Will you all agree with me till this point? Did you all understand how did I obtain this equation where f of d is d power n plus k1 into d power n minus 1 and so on till kn? It's a polynomial function in terms of capital D, which is a differential operator. Correct? Did you all understand till this moment? Now if you get this equation, let us see how to solve this equation. Now step 1, form an auxiliary equation. Sometimes it's also called as indicial equation. So form an auxiliary equation f of m is equal to 0. Okay, so first of all, make this equation homogeneous. For this complete differential equation, we'll obtain the solution in two parts. First part, we'll make this f of x to 0 and we'll see what is the solution of this equation when this equation is homogeneous. Second, we'll consider y is equal to 1 by f of d operating on this function small f of x, and we'll see what is the solution in this case, and we'll sum up both these solutions. Okay, so to obtain the solution of this given differential equations, since we can't do it directly, in first case we'll equate the right hand side to 0 and we'll see what is the solution if this equation is homogeneous, and in second case we'll see what is the particular solution for this particular function f of x and this capital F of d. Okay, so the solution of this involves two parts, which is the complementary function, which we called as CF, and ypi, which is particular integral. Complementary function is the solution of this equation and particular integral is the solution of this equation. We'll see how to evaluate both complementary functions and particular integrals. Is that clear to all of you? Can I go ahead for the next step, next parts? So form an equation and obtain roots of f of m is, capital F of m, f of m is equal to 0. Okay, so now you know this capital F of d is a polynomial equation. So similarly, if this capital F of d is a polynomial equation in terms of d, then this capital F of m will also be a polynomial equation in terms of m. So you know how to solve polynomial equations. So if you know how to solve polynomial equations, you will be getting the roots of f of m is equal to 0. Correct? Of course, if this is a second order differential equation, you know how to solve a second order differential equation. But if it's a cubic equation, you know there are no direct methods to solve cubic equation. By trial and error, you will be able to understand one root. Okay, and of course, I'll give you some points how to find one root of a cubic equation. Okay, fine. So can we go ahead from here? So step 2. On the basis of roots of f of m is equal to 0, roots of f of m is equal to 0. So once you solve this equation, you will be getting some roots. So by looking at the nature of those roots, we write complementary function. Okay, let us shorten this. Complementary function CF of the given DE. So once we will solve this f of m is equal to 0, we will be getting some values of which, we'll be getting some values of m by which we will write this complementary function. We will see how to write them. Means for a particular set of values that you obtain as m values here, how to write the complementary function. We will see shortly. Okay, but right now try to understand. By solving this equation, you will be getting some values for m, and based on that values of m, we will write this complementary function. Okay, is that clear so far? Next, if you can write complementary function, next step 3, calculate particular integral calculate particular integral by considering yp, which is y particular integral, is equal to 1 by capital F of d operating on this function f of x. Okay, now you will be getting yp. Now if you get complementary function and if you know how to write yp, then summing of these two will give you the complete solution of the differential equation. Now complete solution y is equal to y complementary function plus y particular integral, and depending upon the roots of this f of m we will write complementary function, and depending upon this capital F of d and this f of x we will write particular integral. We will see how to write. So in today's class basically we focus on how to write the complementary functions, and in tomorrow in the second part of this higher order differential equations I will show you how to write particular integrals of any given differential equation for a corresponding value of given function f of x. Is that clear to all of you? So shall we start looking into writing complementary functions? Okay, so shall we start writing functions, I mean looking into ways for writing this complementary function? Now look, before that I would like to give you some theory for writing single root of cubic equation. Okay, because sometimes if they give you third order differential equations, then you will be getting this capital F of d as a cubic equation, correct? So whenever you get a cubic equation you should know how to write the solutions for that. Okay, if you know one equation then definitely you can obtain other two. If you know one solution then definitely you can obtain other two solutions. So if I am telling you one thing, if x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus a2 x power n minus 2 and so on plus an is equal to 0, if this is a polynomial function in terms of x, then x is equal to 1 is root of 1. This is equation 1. So x is equal to 1 is definitely root of this equation if a1 plus a2 and so on plus an plus 1. Okay, let me write a naught here for some time. Okay, a naught into x power n plus a1 into x power minus 1 and so on. If sum of the roots of sum of the coefficients of that equation is 0, means whenever you have a polynomial function and if sum of the coefficients is 0, means a naught plus a1 plus a2 and so on an is equal to 0, then definitely 1 will be one root of that equation. For example, you can check x square minus 2x plus 1 is equal to 0. You know, definitely x is equal to 1 is a solution of this. Similarly, you know, x square minus 5x plus 4 is equal to 0. Definitely x will be one solution of this equation. So whenever your sum of the coefficients 1 minus 2 minus 1 and minus 2 plus 1 minus 2 is minus 1 and minus 1 plus 1, it's 0. So sum of the coefficients is 0. So x is equal to 1 will be definitely one root of this equation. Similarly, 1 minus 5 minus 4 plus 4, x is equal to 1 will be one solution of this equation. If you want, you can factorize this. X square minus 4x minus x plus 4 is equal to 0. So x of x minus 4 minus 1 times of x minus 4 is equal to 0. So x minus 4 into x minus 1 is equal to 0 if you factorize. And you can see x is equal to 1 is one root of this equation. Correct? So similarly, for any function or any polynomial, if you are having sum of the coefficients is equal to 0, then definitely x is equal to 1 will be one root of that equation. Is that clear? Is it clear to all of you? Did you all understand this point? Whenever if sum of the coefficients is 0, then x is equal to 1 will be one solution of this equation. Yes. Now, x is equal to minus 1 is root of 1 if sum of coefficients of odd powers of x, sum of coefficients of odd powers of x is equal to sum of coefficients of even powers of x. Sum of coefficients of even powers of x. Even powers of x. Okay, is it clear to you again? So we have things like this. So for example, if you see x square plus 2x plus 1 is equal to 0. you know definitely x is equal to -1 is one root of this. Correct? Of course, it's by common intuition that we can write this equation as x plus 1 whole square is equal to 0. So which means x should be equal to -1. Correct? Because x plus 1 is equal to 0. Similarly, if you take some other equation, x square plus 3x, you know, minus 2 is equal to 0. Maybe. Or you can write plus 2 maybe here. Let me write plus 2 here. Yeah. So here it is 1. So if you see, definitely x is equal to -1 will be one solution for this, because you can factorize this x square plus 2x plus x plus 2 is equal to 0. So if you see, if you take x common, you will be having x plus 2 plus 1 into x plus 2 is equal to 0. So this can be written as x plus 1 into x plus 2 is equal to 0. So which means x is equal to -1 will be one solution of this. So whenever you have sum of, so this is x square, this is x, so this is x power 0. Any constant can be written as x power 0. So if you see, this is, if you see, this is even powers of x, and this one here is odd power of x. Correct? So x square, this is an even number, 0 is an even number. So the coefficients of even powers of x are 1 and 2. So sum of the coefficients of even powers of x is 1 plus 2, which is same as sum of coefficients of odd powers of x. So if this is happening, then definitely x is equal to -1 will be one root of the equation. And many times in exams, they'll give you one of these cases so that you'll evaluate the answer a bit quickly. Clear? And suppose if x is equal to 0, then definitely you can identify there won't be constant term. An is equal to 0. Okay. So these are some tips to identify. Of course, if some of these are not happening, then definitely you should go for trial and error. But these are at least some cases where you can identify one root if an is equal to 0. If this constant is equal to 0, then definitely you can take one x common from this complete polynomial, which means x is equal to 0 is one solution of this equation. Did you all understand these 3 points? Now, if you know one root, then you can perform something called synthetic division and you can get other 2 roots. Or it's also possible, suppose if you have an equation x cube minus 6x square plus 11x minus 6 is equal to 0. Some equation like this, then definitely, you know, since this is a cubic equation, you will be having 3 roots, alpha comma beta comma gamma. Then definitely sum of roots is equal to alpha plus beta plus gamma is equal to minus of this x square value divided by this. You know, basically, what do you say? 6. Alpha beta plus beta gamma plus gamma alpha will be equal to this third coefficient divided by 11. Similarly, alpha beta gamma will be equal to 6. And if you solve these equations, you know, you'll be getting 1, 2, 3 as roots. Because if you see here, 1 minus 6 minus 5 plus 11, 6. 6 minus 6, 0. So sum of the coefficients is 0 and x is equal to 1 will be definitely one root. And normally for this polynomial, if you see, if you have the polynomial like this, a0 x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2 and so on plus an, if you have things like this, then definitely it's obvious that you have n roots of this equation, correct? Alpha 1, alpha 2, alpha 3 and so on, alpha n. You have n roots of this equation. So sum of n roots means sigma alpha I is running from 1 to n. So if you have sum of the roots, which is given by this expression alpha 1 plus alpha 2 and so on, this value is equal to minus a1 divided by a0. Similarly, if you have I is equal to 1 to n, alpha 1, alpha I into alpha I plus 1, similarly means alpha beta plus, alpha 1 alpha 2 plus alpha 2 alpha 3 plus alpha 3 into alpha 4 and so on like this. If you keep on doing like this, then definitely you have, or else you can write maybe 0 to n. So, or maybe n minus 1. By this time you write n minus 1. Okay. Let me write n here. So finally, you will be also having alpha n into alpha naught. Okay. Means basically taking 2 roots at a time. If you take 2 roots at a time and if you do the summation, the answer should be a2 by a0. Similarly, if you go on increasing, taking 3 roots at a time, next option will be minus a3 by a0. So this a1 by a0, a2 by a0, a3 by a0 all comes in this particular format, but there will be a change in minus sign. Okay, for example, you know, ax square plus bx plus c is equal to 0 is a cubic equation, is a quadratic equation for which if you have alpha comma beta are roots, you know, this alpha plus beta will be equal to minus b by a, and also this alpha beta will be equal to c by a. So if you see this, taking one root at a time means the summation involving taking one root at a time will give you this coefficient divided by the basic a0, which is here, and of course with a minus sign, as I have kept a minus sign here. Similarly, if you consider two roots at a time, you will be having c by a. Okay. Similarly, for a cubic equation, if you would like to see bx square plus cx plus d is equal to 0, and if you know alpha comma beta comma gamma are roots of this equation, as I have mentioned here, alpha plus beta plus gamma will be equal to minus b by a. Okay, and now this is sum of the roots, sum of the values taking one root at a time. Now if you take two roots at a time, then alpha beta plus beta gamma plus gamma alpha, this will be equal to c by a. Okay, next, can you tell me alpha beta gamma? If I consider three roots, can you tell me what could be the value of this? Look, you should have the particular coefficient divided by this a, but with an alternative minus signs. So can you tell me what could be the value of this product of alpha beta gamma here? It should be, Suhas, is it c by d? No, it's minus d by a again. Okay, try to understand the logic. This a should be common in denominators at everywhere. You have a naught. Similarly, you'll be getting a naught here. But now this should be a minus sign altered. Okay, so this is what you'll be having. And of course, if you know one root of a cubic equation, you know by something called method of synthetic division, you can calculate other two roots. How many of you don't know what is synthetic division? So please tell me. If you don't know, I will tell you. Tell me honestly, how many of you don't remember what is synthetic division or Horner's method? It's also called by another name, which is called Horner's method. So tell me how many of you forgot calculating that. If there is someone, I'll help you out. No issue. Okay. So I'll tell you. Look, for example, if this is the equation which you have, minus 6x square plus 11x minus 6 is equal to 0. So first of all, try to form one root of, okay, I'm telling you, it's okay. I'll tell you how to perform this synthetic division, or it's also called Horner's method, and I'll show you how to solve a cubic equation. Of course, if you know one root. Now see here. One thing that you should know is, first of all, try to obtain one root by the points that we know. Now if you see, here the coefficient is 1. So 1 minus 6 minus 5 plus 11. 6 minus 6 is 0. So which means sum of the coefficients is 0. So can I tell x is equal to 1 is one root of this equation by this time? Yes or no? Please tell me. Can I tell that x is equal to 1 will be one root of this equation, since the coefficients of all the sum of all these coefficients is 0? Yes. So let us check for minus 1 is a root or not. 1 plus 11, 12, and minus 6 plus minus 6 is minus 12. No, sum of even powers of x is not equal to sum of coefficients of odd powers of x, correct? Because you know these two are coefficients, this 1 and 11 are coefficients of odd powers of x, and this minus 6 and minus 6 are coefficients of even powers of x. So if you see, sum of coefficients of odd powers of x is giving you plus 12, and sum of coefficients of even powers of x is giving you minus 12. So since these two are not equal, definitely minus 1 is not a root. Next, we have a constant here, so x is equal to 0 cannot be a solution for this equation. So we know one root. So now let us see how to calculate the other two roots by Horner's method. Look, first of all, take this root which is available here. Whatever might be the root, if x is equal to 2, then take x is equal to 2. If x is equal to something, some constant k, you can take x is equal to k. And now write the coefficients of all these equations. So coefficient of x cube is 1, coefficient of x square is minus 6, coefficient of x is 11, and constant value is minus 6. So these are the coefficients, and this is x is equal to 1. Did you all understand till now? Till this particular block? Did you all understand till this particular block? Now take 0 here initially. Okay. Now if you take this 0, sum of these two, 1 plus 0 is 1. So now multiply this 1 into 1. 1 into 1 is again 1. So again sum of these two, minus 5. So 1 into minus 5 is minus 5. So 11 minus 5, 6. 1 into 6 is 6, and sum of these two is 0, and definitely you should get the remainder 0 here. Okay. So now since you have divided with x is equal to 1 with this particular term, then definitely this can be written as x minus 1 into, this is the coefficient of x square, because we have divided a cubic equation with x. So this is the coefficient of x square minus 5x plus 6 is equal to 0. This is for how you can factorize this. So if you know that x is equal to 1 root, you can do this, and now it's a quadratic equation for which you can solve very easily. Okay. So you know how to solve a quadratic equation. So definitely, which means by solving this equation here, that implies solving that cubic equation. And now you can get the values of x is equal to 1, 2, 3 as roots of this equation. Okay. Because you should solve this polynomial functions in terms of d, I gave you all this data. Okay. In some exams, this equation was asked. So it's not like whatever the value you get here, you need to dump here, but you need to multiply this value with this and then you need to put it here. Okay, but since we have a special case here, x is equal to 1, whatever you are getting here, you are getting the same things here, but it need not be mandatory all the time. Okay, these values which you are substituting here should be substituted by the product of this with the remainder. Is that clear to all of you? Now, did you all understand how to solve a cubic equation whenever you are getting some cubic equation in this differential equation, whenever you are converting this into auxiliary equation and equating f of capital F of m is equal to 0? Yes or no? Did you all understand till this moment? For this differential equation, if I want to write complementary function, I want to solve this auxiliary equation. So if this is a cubic equation in some cases, I hope you understood how to write this. Yes? Okay. So see here. Now, yeah. So now we know how to solve some cubic equations and basically how to solve this auxiliary equation. So now by looking at the solutions of auxiliary equation, I told you how we will be writing complementary functions. So let us see that. The important part, writing complementary function of a higher order degree. Complementary function of a higher order DE. Higher order DE. I think we spent some 10 minutes on that. It's okay if you are understanding the things. Okay, so this is what you have now. Now, on solving capital F of m is equal to 0, which is the auxiliary equation. First point, if roots are of the form, m1, m2, m3 and so on, where all these are real numbers. So m1, m2, m3, and of course if these are integers, to be more precise, if these are integers, you know, sometimes if you solve a equation m square minus 5m plus 6, this is a differential equation and you will be getting some values here, you know, for example 2 comma 3, then you know these are integers, correct? Or similarly there can be some fractions also. So let us make this as some real numbers, to be more precise. Okay, real. Okay, if these are real numbers, then whenever you are getting some real numbers, then the complementary function is, YCF is equal to C1 into e power m1x plus C2 into e power m2x plus C3 into e power m3x and so on. Okay, this is the complementary function where the C1, C2, C3 are arbitrary constants. Is that clear? Suppose if you are getting all these as real roots, then definitely, or of course you can talk one thing, this is real and rational, of course. Okay, rational roots means basically some integers, some fractions and all. So if you are getting them, then definitely this is how you will be writing the solution. Okay, these are real and rational roots of the equation. You know, definitely for any equation there should be 3 kinds of roots that are available: real and rational, real and irrational, and finally complex roots. Correct? Means if you solve any equation, you will get the values something like this, or some irrational numbers, involvement of some irrational numbers, and finally you can get either complex numbers. Yes or no? And also, you know, these 2 kinds of solutions will have their conjugate pairs. Means if a plus root beta is one solution, then definitely alpha minus root beta will be another solution. Similarly, if alpha plus I beta is one solution, alpha minus I beta will be another solution. I hope you know irrational roots and complex roots occur as conjugate pairs. Do you know this? For any polynomial function, if you solve this, if there is one root of this kind, then definitely there will be second root of this kind. Clear? Do you know what is conjugate pair and all? Yes. So now let us get back. So this is the way. Now sometimes there could be a possible chance that out of all these n roots, suppose if this is a polynomial of nth degree, now out of these n roots there can be chance that 2 roots will be same, correct? So if the roots are, m1 comma, let us suppose this m1 is repeated one more time, and then m2, m3 and so on, things like this, then complementary function CF is equal to, since this m1 is repeating twice, we will write C1x plus C2 times of e power m1x. Okay, this is what you will be writing. So did you understand? If the root is repeated once, you will be writing C1x plus C2, where the C1, C2 are arbitrary constants, into e power m1x. And of course, for these terms which there are individual real roots, same again as this. So C3 into e power m2x plus C4 into e power m3x and so on, things like this. Okay, so clear? If the root is repeated once, do you know how to write the complementary function now? We'll write the C1x plus C2 in terms of, in multiplication of this e power m1x here. Now I'll give you one case. Will you write complementary function for that? Look, if roots are m1 comma m1 comma m2 and finally we have some real roots like this, then can you write what is the complementary function for this? Or I'll write some complementary function. Please tell whether that is correct or wrong. Okay, since it will take some time for you to type all these functions in the chat box, so please, I'll be writing the complementary function. Tell me whether that could be correct or wrong. C1x plus C2 into e power m1x plus C3 plus C4 plus C4 e power m2x plus C5 e power m3x and so on, things like this. Of course, C6 into e power m4x and all. Is this equation correct? Can I write this as complementary function? Since we are getting m2 two times, can I write as sum of two constants? No, it's not correct because we have one x here. Correct? Now this is correct. Yes. Now this is completely correct. C3 into, we should have 1x as similar to this m1. Next, if the roots are something like, let us suppose m1 got repeated 3 times now. m1 and then m2 got repeated twice and m3 has got once and so on like this. Then ycf is equal to, can you tell me what will be the coefficient of e power m1x in this equation of complementary function? Can you tell me what will be the coefficient of e power m1x in this equation, in this complementary function? Coefficient of this e power m1x, c1x square plus c2x plus c3, correct. So we'll write c1x square plus c2x plus c3 into e power m1x, and since m2 is getting repeated twice, we'll write c4x plus c5 e power m2x plus c6 into e power m3x and so on, things like this, correct. Now, did you all understand how to write the complementary functions if the roots are real and if they are getting repeated any number of times? Please say yes or no. Did you all understand how to write complementary functions as long as the roots are real and rational? Yes or no? Please respond. All of you, did you understand how to write the roots of, the complementary function of any given differential equation as long as the roots are real and rational? Now, let us see what is the case if they are irrational. If roots are of the form alpha plus root beta, then definitely if alpha plus root beta is one option, then definitely alpha minus root beta will be other root. And let us suppose we have some real roots also, m1, m2 and so on. Then the option, if these are the two roots, alpha plus root beta and alpha minus root beta, then y complementary function is written as, look, for these two complementary functions, for these two roots, we'll have e power alpha x into c1 cos h. This is hyperbolic function. You know what is sin h and cos h? If you don't know, I'll tell you after this. Root beta into x plus c2 into sin hyperbolic of root, there is no multiplication here, sin hyperbolic of root beta into x. This x won't lie within this beta, within this square root. Okay, so this x is something out of square root. So this is the function or the solution for the complementary function corresponding to these two roots. Plus, now for the real roots, again same thing, c3 into e power m1x plus c4 into e power m2x and so on. This is what you have. Now, did you understand if these are two roots which are given by alpha plus root beta and alpha minus root beta, then the complementary function of the differential equation it can be written as e power alpha x into c1 cos hyperbolic of root beta x and c2 sin hyperbolic of root beta x. You know what are hyperbolic functions in general? So cos hx is nothing but e power x plus e power minus x by 2 and sin hx is nothing but e power x minus e power minus x divided by 2. This is what you have. Okay. So these are hyperbolic functions. Okay. where e power x plus e power minus x by 2 is for cos hx and e power x minus e power minus x by 2 is for sin hx. Okay, I hope that's clear for you. So by this time, if there is root beta x here, you know how to write cos of hyperbolic of this function and sine of hyperbolic of this function. Generally in exams, they don't go for e power x expansions, but they just give you this cos in terms of cos hyperbolic of root beta x and sine hyperbolic of root beta x. Clear? Did you all understand how to write the roots? I mean, how to write the complementary function if the roots are real but irrational? Yes or no? Clear? Did you understand this? This part is common, which is very well known to you from here. Now, this two roots will imply this part in the complementary function. Did you understand this? Okay. Now, let us see what is the case if this real and irrational roots are getting repeated. Let us see that. If the roots are alpha plus root beta x, alpha plus root beta, alpha minus root beta, and let us suppose this pair is getting repeated one more time. Alpha plus root beta, alpha minus root beta, and of course again you have something like m1, m2, m3 and all. Now, can I write this y complementary function is equal to e power alpha x into c1x plus c2 times of cos h root beta x plus c3x plus c4 times sine hyperbolic of root beta times x plus then it's common c5 e power m1x and so on, things like this. Okay, plus so on. Okay, look, because these roots are repeating for this constant c, in case of real functions, real and rational functions also you have seen, if these roots are getting repeated, then in place of constant we will be writing c1x plus c2. Same is the case if you adopt for this sort of roots. Since we are putting this constants in this part of cos and sine, definitely whenever these roots are repeating, these constants c1 and c2 should be replaced with c1x plus c2 and c3x plus c4. Did you understand the logic? Whenever the roots are repeating, the arbitrary constant will take a linear form if the basically if the roots are getting repeated only once. If the roots are getting repeated twice, then the arbitrary constant will be written as a quadratic function c1x square plus c2x plus c3 and so on, and then we'll write whatever is required, e power mx or cos hx depending upon the type of root. Did you all understand till this point how to follow if you have this irrational roots getting repeated? Yes or no? Please respond. If you understand this, then I'll go for imaginary roots. Okay, so see here, if roots are of the form alpha plus I beta, comma, if alpha plus I beta is one root, then definitely alpha minus I beta is also going to be one root. Similarly, m1, m2 and so on, things like this. Then complementary function ycf is equal to e power alpha x into c1 cos beta x and plus c2 sin beta x. And of course, for this real and rational roots, it's common c3 into e power m3x plus c4 into e power m4x plus and so on, things like this. Okay, so that main difference between this irrational root and this imaginary root is here these are normal trigonometric functions. This is c1 cos beta x and c2 sin beta x, but here we are going for hyperbolic functions. Okay, and of course this square root of b, and here there is only beta, you can see here. Did you understand the main difference between how to write complementary functions whenever you have real but irrational roots and also imaginary roots? Did you understand these two things clearly? Yes. Now let us suppose I have one pair of this roots getting repeated. If roots are something like alpha plus I beta, comma, alpha minus I beta, and let us suppose this pair of roots is getting repeated again, alpha plus I beta, comma, alpha minus I beta, and also we have m1, m2 and all, things like this. Of course different roots. Now can you suggest me any editing here? In place of this c1, what should I write now? In place of this c1, what can I write now? Please tell me. In place of this c1 here, when writing the complementary function of this case, what can I write in place of c1? All of you, please respond. What can I write in place of c1? c1x plus c2. Correct? Good. It should be c1x plus c2 or c1 plus c2x. Doesn't matter. Basically, one arbitrary constant into x plus another arbitrary constant. So if you see e power alpha x into c1x plus c2 times of this cos beta x plus C3x plus C4 times of this sin beta x. See, in exam, don't get confused whether this is sin beta x or cos beta x. You can substitute anything because these are just arbitrary constants. Okay. Now, while substituting in the basic initial conditions and all in this solution, you should be a little bit careful with calculations. That's it. Okay. So, don't in exam, if you don't remember whether this is cos beta x or sin beta x here, please don't waste your time. You put anything and you can form the differential equation. Then, while substituting the boundary conditions, please calculate a bit carefully. Okay. Nothing other than that. So plus C5 e power m1x plus C6 e power m2x and so on. Things like this. Now, I'll give you one thing. Please try to answer. If roots of f of d or f of m is equal to 0 are alpha plus I beta comma alpha minus I beta, then a plus would be comma a minus would be, and of course m1. Let us suppose this is a 5-degree polynomial. So when solving this, you will be getting 5 roots. So can you tell me what is the complementary function for this? Corresponding to this alpha plus I beta and alpha minus I beta, we can have e power alpha x into c1 cos beta x plus c2 sin beta x. Correct? Next. Plus corresponding to these two roots, a plus would be and a minus would be, we have e power ax into c3, because two arbitrary constants we have already taken. So cos hyperbolic of would be x plus c4 sin hyperbolic of would be times x. This is one thing, plus c5 of e power m1x plus and so on. Correct? Will you all agree with me? Now, if I write the solution for this in this way, yes or no? Please do respond. Do you all agree with me if I write the solution for this in this particular way? Yes? So, now you know how to write the complementary functions if the roots are real and rational, and also you know how to write when the roots are real and also irrational, and also you know whenever the roots are imaginary. Correct? And you know how to write the complementary functions, means how to modify the arbitrary constants function if roots are getting repeated. Yes? So can we go for start solving problems? So by this time you know how to write complementary functions of any given high order differential equation, as long as this is just a polynomial function, means the coefficients of the differentiations are just constants. Okay, they are not any functions of x. So these complementary functions are available only when you have this k1, k2, k3 and all. So basically all these k1, k2, k3 and so on, kn are just constants. Okay, sometimes there can be chances where we have functions here but of x, of course, but now we are dealing only the case as far as GATE syllabus in general is concerned, excluding xc, we have only things with only constant coefficient. So if it's a constant coefficient, then definitely this will be a polynomial, and of course the cases which we have dealt till now are just the cases for polynomial functions. So clear? Did you all understand? As long as we have some constants in as coefficients here, how to write the complementary functions? So we'll straight away solve few problems now. Yeah, so now please try to solve this problem. Solution. And of course, if the equation is homogeneous, means if the right hand side is homogeneous, then is 0, then you say the differential equation is homogeneous. Since you know complete solution y is equal to complementary function plus particular integral, and what is this particular integral? Particular integral is equal to 1 by f of d operating on this small f of x, which is on the right hand side of this equation. So now if this f of x is 0, which means if the differential equation of higher order is homogeneous with a 0 here, then definitely this particular integral will be 0, which means the total solution is same as complementary function. Clear? Is that acceptable to you? Please tell me, whenever your equation is homogeneous, this small f of x will go to 0, then which means this particular integral will be 0, which means the complete solution of this differential equation will be same as the complementary function of this differential equation. Is that clear to all of you? So can I go ahead? Yes or no? Please respond. I hope you are very busy in solving the answer for this question. Okay. So please try to answer this. So solution, if you see d square y by dt square plus 2 dy by dt plus 2y is equal to 0. So normally if you form the differential equation, it is something like d square plus 2d plus 2 operating on y is equal to 0. So this is your capital F of d, correct? So now you can write the auxiliary equation as m square plus 2m plus 1 is equal to 0. Now let us try to solve these equations. It's obvious the roots of this equation will be, since this is m plus 1 whole square plus 1 is equal to 0. So m is equal to minus 1 plus I and minus 1 minus I. Correct? You know I is nothing but square root of minus 1, which is obtained when you take square root of any negative number. Okay. So these are the two roots, minus 1 plus I and minus minus 1 minus I. So this is alpha plus I beta form, and definitely this is alpha minus I beta form with alpha is equal to minus 1 and beta is equal to 1. So can you write solution of this equation? Plus 2, which is plus 2? I think some options are given here. What do you mean by writing plus 2, Sridevi? Please tell me. You feel 2 is one root of this equation? Yeah, correct. I made a mistake here. That's what you are trying to tell me. Okay. This is plus 2. Okay. Good. Fine. Even though this is correct. Okay. Because when I'm writing this step, my mind is thinking about this step. So I have made it. Yeah, 2d plus 2. Correct. Okay. So now, but I hope I have done it correctly. So now if you see the solution or the complementary function for this, since this is homogeneous, this is the complete solution, which we can write as e power alpha x. So e power minus 1 into x into c1 cos beta x. Beta is value is minus 1. So c1 cos x plus c2 sin x. This is what we have. So to evaluate these two constants, you should have two differential equations, which are given here. Y of 0 is equal to 0 is one condition, and dy by dt at t is equal to 0 is minus 1. So if you want, you can solve this. Y is equal to e power minus x into c1 cos x plus c2 sin x. So this is what we have. Now, if you take c1 sin x plus c2 cos x also, doesn't matter, but whenever you are substituting these conditions, you should be careful with calculations. Okay. So now, if you are doing y of 0 is equal to 0, means y is equal to 0 at x is equal to, or since this is given in t, t is equal to 0. Let us write all these equations in terms of t. Okay. Let us write all these equations in terms of t, because we are having t as an independent variable here. Okay. So y is equal to e power minus t c1 cos t plus c2 sin t. This is what we have. So if you are substituting that here, e power minus x into c1 cos t plus c2 sin t. Now tell me here carefully. When you put t is equal to 0, y is also same as 0. Correct? So can I write y is equal to 0 is equal to e power minus 0. This is t, I guess. Yeah, this should be t. So y is equal to 0. T is equal to 0 means 1 into c1 cos 0 is c1 plus c2 sin 0 is 0. So which means, can I tell c1 is equal to 0? So if c1 is equal to 0, then definitely you will get something for c2. Y is equal to c2 into e power minus t sin t. This is what you have. So get the value of c2 by finding dy by dt at t is equal to 0 and equate it to y minus 1. So if you do that, what's the answer you'll be getting? Dy by dt at t is equal to 0 is minus 1. So please tell me what you'll be getting for that. Minus 1 is equal to c2 into e power minus t into cos t. So that is 1. And this is also 1. So c2 is equal to minus 1. So if c2 is equal to minus 1, then this d is the solution for this. Correct? E power minus t into sin t. And of course, this is a previous gate question actually. Yeah, c2 is minus 1. So definitely you can get. See, when I am doing some calculations like this, I'm not writing everything clearly. Okay. So I hope, because these are simple things, you know how to differentiate this function, then how to put t is equal to 0. Okay. We have spent enough time on differentiation in our first module. So I'm not going there again. Okay. I hope things are clear. Yes. So can I go for the next question? All of you please respond. Can I go for the next question? I hope all of you understood this. Or if there is any doubt, you can talk to me. There is no doubt. Correct. So I am going for the next question. So this is the next question. So please try to solve this. Which one of the following transformations, means basically the substitutions, u is equal to some function of y, by taking u is equal to one of these functions, this equation, which is of course non-linear, a first order differential equation, this is y cube, to a linear differential equation. So by making some substitution, this non-linear differential equation which is here gets converted to a linear differential equation. They are asking you what's that particular substitution you need to make. Okay. So let us do that. Dy by dx plus by is equal to a power, a into y cube minus sign, of course. So minus ay cube. So if you divide with this, you will be getting y power minus 2 into dy by dx, sorry, minus 3 into dy by dx plus y power minus 2 times of b is equal to minus a. So by the help of this, since we have dealt already this case where you have a Bernoulli equation here, whenever there is y power n here, this is greater than 1. So we have something called Bernoulli equation. Today in the beginning of the class we have talked about it. So if this is Bernoulli equation, now can you tell me what could be the substitution that we need to make from this to convert this into a linear differential equation? Do you all remember in today's class, if you have y power minus n into dy by dx plus y power 1 minus n into some function of p is equal to some function of x, then the substitution that we made to convert this nonlinear equation to linear differential equation is taking this part as some variable z. Here they have given u is equal to some function, so here we are considering this as u, hopefully. Okay, so u is equal to y power minus 2 is the transformation which converts this non-linear differential equation to linear. And as I told you, sometimes they're asking you what is the substitution you need to make in exam. This is one such question which was asked in GATE. Okay, so please be careful and try to answer these kind of questions if they come in GATE. Sometimes they don't ask you to solve complete equations, but they'll ask you some key points where we, some key points that help us to solve differential equations. Clear? Is that fine to all of you? So can I go for the next question? Can I go for the next question? Whoever is on live by just this moment, if you want this, you can watch the first 5-10 minutes of today's class. Okay, you will be getting the answers. Since the people who are here are constantly staying in the class, they are able to answer very quickly. Okay, and they understand what is this. I'm telling you, so please be regular to the classes. Don't attend one class then skip one class, and don't do like this, because this is a revision course. Okay, we'll be covering the things very fastly, and also I'll be putting more focus on the topics where questions are being asked very frequently. Okay, so it's like if you attend all these classes, hopefully if things are fine, you will be getting all out from engineering mathematics. Okay, so please don't miss these classes. Okay, fine. So I'm going for the next question. So this is next question. It was also a previous GATE question. So please try to solve this. Which one of the following differential equations has a solution given by y is equal to 5 times of sine 3x plus pi by 3? This is what they have given. And normally see, they will be giving you differential equation and you will solve. But it's this is a question of the form, forming a differential equation. So some solution is given and they are asking you, this is the solution of which of these following differential equations. Okay, so please try to do this. Y is equal to, this implies y is equal to 5 times of, let me expand this, sine a plus b form I have given you already. So sine a cos b, cos 60 is 1 by 2 plus cos b and sine c, sine 60 is root 3 by 2. So basically y is equal to 5 by 2 times of sine 3x plus root 3 times of cos 3x. Can you understand something from this? If this is 1 and if that is root 3, of course, if you compare this with some standard differential equation, can you understand something? Please try to solve this. C is the answer. D square y by dx square plus 9y is equal to 0. How come? How can you say that C is the answer? Because this is the case in general for a second order differential equation, and this is of the form e power alpha x into c1 sin beta x plus c2 sin c2 cos beta x, means you'll be having some combination of sin and cos when the roots of this complementary or the roots of this particular equation are of the form alpha plus I beta and alpha minus I beta. Reverse कर देंगे. Okay, fine, you can reverse always. In exam, if you don't remember this point, see, basically my intention is to tell you that we have a combination of some sin 3x and cos 3x, which means this equation must have obtained some roots which are having the form alpha plus I into 3 and similarly alpha minus I into 3. Then we will be getting sin 3x and cos 3x here, and of course this is some condition that you have here. Can you differentiate 2 times and solve? Yes, of course. Since this solution is given, you can differentiate 2 times. If first of all, if you differentiate 1 time, you'll know whether any one of these 2 is answer or not. If you differentiate for the second time, then definitely you can know whether this is answer or not. Okay, I think your answer should be something C. Correct? Did you understand? You can differentiate this given function once. So since it's given, what could be dy by dx value? Definitely, this won't be your dy by dx. Means from this equation, dy by dx is equal to 5 by 3 times of cos 3x. But if you differentiate this once, you won't get 5 by 3 of cos 3x. Similarly, you won't be getting this option also. Correct? Because when you differentiate only once, this 3x plus 5 by 3 should be there inside this cos. But we have only 3x. Okay. So both A and B are wrong answers, because if you are differentiating only once, then definitely you should have 5 times or 15 into cos 3x plus 5 by 3, which is not there in any of these options. So if you differentiate for the second time, definitely you will be getting this as the correct option. Okay. And also from this logic also you can understand the same thing. Is that clear to all of you? Did you all understand how to identify the solution, the differential equations whenever solutions are given? Is that clear? Yes? Did you all understand how did we solve this? Yes. Okay, these are 2 different logics. One thing, you can differentiate the functions, or else by looking at the kind of solution you can identify something. Fine. So let me go ahead for this. Did you all understand the previous problem? Yes or no? Please respond, because I couldn't see your faces now. So chat box is the only way I can understand whether you are understanding the things or not. Okay, so please type in the chat box, or if there is some doubt for you or some difficulty you are facing, you type that thing in the chat box. I'll talk about that. Okay. So please try to solve this question. If A and B are arbitrary constants, means in this given solutions A and B are arbitrary constants, then the solution to the ordinary differential equation, which is given something like this: d square by dy, d square y by dx square minus 4 times of y is equal to 0. Tell me once right side logic, sir. Previous question. Okay. See, whenever you don't understand, you can talk always. Okay. So if these are the roots, then definitely the solution will look something like e power alpha x into c1 cos 3x plus some constant c2 sin 3x. Correct? Yes or no? If these are the roots, then this is the solution. Correct? So which means the solution should involve some constant into cos 3x plus some constant into sin 3x. This is what exactly you are seeing here. Some constant into, or 5 by 2, some constant 5 by 2 into sin 3x plus also some constant 5 into root 3 by 2 into cos 3x. Correct? Yes or no? Can you understand if I multiply this 5 by 2 inside, for example, 5 by 2 and of course again 5 root 3 by 2. Then can you see, Sridevi, that these two are looking similar when alpha is equal to 0? Of course. Yes or no? Can you see that this term which is here and this term which is here, both are looking similar? So which means your option should be something like this, which means you should have a differential equation which is having imaginary roots for its auxiliary equation, which is happening only in this case with option C. Okay. Yeah, this is the question. Basically, it's given. D Calimula. Let me solve. So the auxiliary equation will be d square minus 4 is equal to 0. So which means m square is equal to 4. So m is equal to plus or minus 2. So y is equal to e power 2x of c1 plus c2 into e power minus 2x. This is the solution. Correct? Now, what are the options? Y is equal to a sin 2x, y is equal to a cos h2x plus b sin h2x, and of course these are the cases. Now, got it? Fine. So see here. Now, if you talk about this question, look, there is some involvement of e power 2x and e power minus 2x. Now, can you tell me one thing? If you take this option, this is a linear function. So this is not the solution. Similarly, if you take this option, this involves e power minus x, but this question involves e power 2x and e power minus 2x. Now, if you consider this cos h2x and sin h2x, let us suppose I am simplifying this option. A times of e power 2x plus e power minus 2x by 2 plus b times of e power 2x minus e power minus 2x by 2. And from this, if you take common, you will be getting a plus b by 2 of e power 2x plus a minus b by 2 of e power minus 2x. Yes or no? And can I treat, since a, b are constants, are arbitrary constants, it's given here. So this will also be an arbitrary constant and this will also be an arbitrary constant. Which means, can I tell that the option in option D and this solution both are analogous to each other? Yes or no? Can I talk this? Can I tell that this option D and this solution which you obtained by this analysis both are analogous? Because hyperbolic functions involve exponential combinations. Yes or no? Please respond. Did you all understand that why this option D is something similar to or same as this option Y? I mean this function here. Because if a and b are arbitrary constants, then any combination of this a and b is also a arbitrary constant. Correct? So D is the answer. And of course, you know, sin x and cos x doesn't involve any exponential terms in them or in their expansion. So there is nothing to talk about that. So finally, this is the one question. So please try to solve this. Again, some GATE 2010 ECE. I hope you got yesterday's notes. I mean, notes of the classes till yesterday. Correct? You got all the notes in Telegram channel of the classes till yesterday. Fine? So there is no issue with notes now. Anyhow, today after the class, I will be uploading these notes also. Or we'll do one thing. Tomorrow, we'll upload the notes of complete both parts. Yesterday's part and today's part. Okay. So today I won't upload any notes. Tomorrow, I'll upload the notes of both today's class and tomorrow's class. Because tomorrow is also the class of higher order differential equations. I'll merge these two into a single PDF and I'll then send you. Okay. What's the time, by the way? It's 10:47. Okay. So let us continue. What's the answer for this question? Meanwhile, a function n of x satisfies the differential equation d square by dx square minus nx by l square is equal to 0, which means the auxiliary equation is something like m square minus 1 by l square is equal to 0. Correct? So m is equal to plus or minus 1 by l. So solution is n of x is equal to e power 1 by l into x, which is x by l. Of course, some arbitrary constant c1 into c2 into e power minus x by l. This is what we have. Correct? So basically, n of x is equal to c1 e power x by l plus c2 e power minus x by l. Okay, so this is the solution. So now I think some conditions are given so that you can evaluate these things. N of 0 is equal to k. So when x is equal to 0, this function n of x is k. So k is equal to, if you put these zeros in place of these two, c1 plus c2. This is what you have. Similarly, n of infinity tends to 0. So 0 is equal to c1 into, when n tends to infinity, this tends to infinity. So some very big value, and plus whenever this tends to infinity, e power minus of something is 0, which means this c1 has to be 0 definitely. Correct? Whenever some big value is there, then definitely the multiplication of this with respect to 0 should be, I mean, you know, in differential equations or in any other mathematical terms, if the complete solution is getting affected by a few terms, something like this, then we'll eliminate this arbitrary constant, because this arbitrary constant is in our hands, so you can equate this to 0 in order to have some finiteness for the problem. Correct? Yes or no? In order to have some finiteness for the problem, since this arbitrary constants are in our hands, whenever we have the functions that are giving some infinite values, we'll take that arbitrary constants to be 0. So C1 is 0, which means this n of x is C2 into e power minus x by L, and you know C1 plus C2 is k, and if you are equating this C1 to 0, then definitely C2 is equal to k, so this value is equal to k. So k times of e power minus x by L, which is in option D. Okay, look, whenever you have some differential equations, then for the solution to be a finite, for having the finiteness of the solution, then definitely whenever you have some functions involving infinites and infinite, I mean some values which are not finite, then since this arbitrary constant is in our hands, we'll select the arbitrary constant in such a way that definitely this arbitrary constant tends to 0. Okay, in order to have finiteness for the problem. Is that clear to all of you? Yes or no? Did you all understand this problem or no? Did you all understand why did I take C1 is equal to 0? Normally you feel that this C1 into some quantity is equal to 0, and this means C1 is equal to 0 by a very big value, which is 0. Okay. So the answer for this is k into e power minus x by L. Did you all get this when calculating the solution for this problem? Did you all get this when you are trying to achieve solution for this problem? Yes, how many of you got it? Please tell me. How many of you got this solution? N of x is equal to k into e power minus x by L before solving? I mean, before I solved the actual answer. Got this? Yes, good. So let us solve few more questions before today's class. Oh, I think. Okay. Yeah, please try to solve this. You got it, Ovila? Good. Mauli? Fine. I'll ask you one thing. You do that. If you are liking the session, please definitely like the videos, and you can share them among your group, so that since GATE is very short in duration, so definitely they'll be of some help to all the aspirants as well. Okay, so whoever is writing GATE, any branch, they'll be having mathematics in their GATE syllabus definitely. So these videos, since syllabus is almost common to any one of you, 80% or 75% of the syllabus is definitely common to all of you. So you'll be getting benefited by this. Okay, and also if you are here on this channel for the first time, you can always subscribe the videos, so that you know you will be getting notified whenever the lectures are conducted here. So what is the maximum value of this, by the way? Please tell me. The differential equation is y double dot of t. You know, sometimes the differentiations are denoted by dots. For example, y dot means this implies dy by some variable. If the independent variable is t, dy by dt. Y double dot is nothing but d square y by dt square and all. Okay, this number of dots denotes the order of the differentiation. Okay, so that is y double dot of t means. So y double dot of t plus y of t is equal to 0. Now it's undoubtedly the auxiliary equation for this is m square plus 1 is equal to 0. So m is equal to plus or minus I. This is what you have. So y of t, if you are writing y of t, the solution is, since this is imaginary roots, so e power alpha x, which is e power 0 into x, 0 into t into c1 cos t plus c2 sin t. This is what you have. Okay, now two initial conditions are given. Y dash of 0 is equal to 1 and y of 0 is equal to 1. So if this is y of t, y of 0 is equal to 1 implies 1 is equal to, since this value is 1 always, so c1 cos t, which is c1 into 1 plus c2 into sin 0 is 0. So c1 value is equal to 1. So which means y is equal to, since c1 is 1, the question is cos t plus c2 sin t, since we need to find what is the value of c2. Now for giving this, they have given y of 0 is equal to 1. I mean y dot of 0 is equal to 1. So y dot is nothing but minus sin t plus c2 cos t. This is what it's given. So from this we'll also get c2 is also same as 1. So which means the solution of this equation is when c1 and 1 and c2 is also equal to 1, y of t is equal to sin t plus cos t. This is the function which I have as the exact or particular solution for this problem under these given initial conditions. Now you need to find the maximum value of this function. Normally if you want to do, you can RT2. What is RT2? D root 2. Okay, you mean RT stands for R over OT. Okay, fine. So see here. Now normally if you have this function, you have many methods to find maximum of this function, correct? How you can find? First thing, you can always differentiate this, equate it to 0, then you can get stationary point, then find the second derivative. You can check whether the stationary point is giving maximum or minimum for this function, then you can calculate the maximum values. This is how, or what's the procedure we have obtained in concepts of maxima and minima. But I gave you a shortcut for things like this, correct? If you have any function like a sin x plus b cos x plus c, can you tell me what's the maximum value of that function? If f of x is equal to a cos x plus b sin x plus c, can you tell me what's the maximum value of that? Yes, c plus square root of a square plus b square. People who attended my maxima and minima class, they'll be able to tell this because I have given them. So if there is any function of this form, a sin x plus b cos x plus c, then the maximum value of this function is c plus root of a square plus b square, and the minimum value of this is c minus root of a square plus b square. This is what you can have. This is maximum, and of course this is minimum. Okay, please make this note because these kind of points are helpful for solving this kind of at this moment. Okay, so the maximum value of this will be c 0 plus square root of 1 square plus 1 square, which is square root of 2, which is an option D. Okay, normally if you don't know this point, again you need to obtain the procedure for maxima and minima, and you need to find what the maximum value of this function. But there is no necessity of doing all those things. Simply you can use this result. Clear? I hope things are clear. And it's 10:56 already. Okay, so let me stop here at this moment for today, since we have another part for higher order differential equations tomorrow. We'll complete these questions, and then we'll see how to write particular integral of some differential equations, and also we'll see some special type of equations called Cauchy-Euler equations, which are being very frequently asked in recent times. Okay, especially from 2019. So please don't miss tomorrow's class, because in tomorrow's class we have learned only half part, correct? We have seen only how to write complementary functions. We have not yet seen how to write particular integrals. So in tomorrow's class we'll see how to write particular integrals, and also of course how to write complete solutions by knowing this complementary functions and particular integrals. And then we'll move on to something called a special type of equations called Euler-Cauchy equations. Okay, so please don't miss tomorrow's class. And of course, if you are here for the first time, then I would like to give you some things for you at this moment. So of course in tomorrow's class we'll be continuing this lecture of higher order differential equations anyhow. And of course, if you are here for the first time, I would like to talk something about our details. So this is engineershub.com. This is the URL for getting access to our website, so that you will be knowing what we are doing here. Okay, so you'll get the information about different courses and batches that we are launching here, and notes after every class will be posted in these two Telegram groups. Of course, the group on my right is for exclusively mechanical students. You can join this group just by scanning this QR code with your mobile camera. So there will be some link, you can connect to us. Similarly, ECE, EEE, CSE and chemical, whatever, all other branches excluding mechanical, you can always go for this particular link. Okay, so the notes of every lecture that's being taken on this platform will be uploaded here, and these are the official phone numbers. You can contact to any one of these phone numbers and get the information about any of the gate trainings and all. And also of course for any guidance you can contact to these numbers. And this is the official location of our institute, Engineers Hub. It was located in it's located in Visakhapatnam in Daba Garden. So if you are free to visit, you can definitely visit us and see us in the office, and we'll be most happy to receive you and see you here. Okay, so please don't miss tomorrow's class. And definitely today I won't be uploading notes for higher order differential equations, because we have a second part tomorrow. So we'll upload both these notes as a single document tomorrow. Okay, so is that clear to all of you? And are you all learning something from this lecture series? And if you are liking the content that's being shared here, you please like the videos, share them, and also subscribe to the channel if you are here for the first time. Okay, if you are learning something, please type some heart symbol in the chat box. I would like to see that. Okay, if you are liking the content that's being shared here, you can always put a heart symbol in the chat box. Let's see how many hearts we shall get. Okay, thank you. You're welcome, of course. Ranjita Murugan, I think you are from Tamil Nadu, correct? I have been in Chennai for past 3 years. Yes. Okay, so fine, thank you all, good night, have a nice sleep. We'll meet tomorrow sharp at 9 p.m. and we'll continue our lectures. Okay, and we'll see how to write the complete solution of a differential equation, and also we'll visit a few more things. Thank you all for being patient over this lecture. Yeah, good night, thank you all.